We have seen till now what is an entity, we have seen what is a relationship, and we have seen conditions under which we can put attributes in one entity and the reasons why we define a new relationship over entities, because the difference between them is the difference among certain constraints. This has got certain flexibilities and this has got certain constraints, in the sense that in every entity set we must have, every entity of the entity set we must have all the attributes properly filled up. This is our constraint. Therefore, in case a staff does not have a telephone number, we cannot put the attributes of this into the staff. We have to put them out separately as a separate entity set and have this relationship. Now we will come to some other interesting constraints. These constraints help to characterize the type of mapping relationships that we have. So these are called mapping constraints. Now before we go on to mapping constraints among entities, therefore the mapping constraints among relationships, we will try to understand the different types of constraints that can occur between any relationship of two sets. We already know from basic mathematics that we have got the following types of mappings between two binary relationships. One means that for if there is a mapping between these two elements, then there cannot be a mapping between this element to any other element here or this element to any other element here. One defines this situation, that elements must be mapped to, if they are mapped, they will be mapped to only one element. One means one from this side, this element can have only one mapping here and this element can have only one mapping here. But this does not mean that an element must be mapped to somebody else. That is a different property called surjective property. One many means one to many. It is a directional mapping always. This can be mapped to more than one element. But this can be mapped to only one element. One to many. From this side, if it is one to many, then this element can be mapped to more than one element. But many elements from here cannot be mapped to here. Yes, one element can map to many elements. That is all right. Many one means from this side many elements here can map to one element. And many allows both. It allows this as well as it allows this. This is 1 this is one many, this is many one, and this is many. but none of them define the subjectivity, in the sense that in all of them there may be elements which are not mapped to anybody. That is the definition of these one many, many many, one one, many one, which we will use. And these constraints will be put in the ER diagram or the entity relationship diagram that we give. Let us come to the original diagram which we were trying to do. Let us come to this simple diagram. How do we specify these mapping constraints? Books to users, the mapping constraints will be specified on these links. If on any entity we put this, then this participates, then this entity from this to any other entity will participate in a one-to-one or one-to-many relationship. When we write down this arc on this relationship, then this entity will participate in a one-to-one or a one-to-many relationship. On the other hand, if we write down a link without an arrow, then it means that this to any relationship, this entity will participate in a many to one or a many to many relationship. Now let us come to this example. There are no links here. If there are no links here, this means that this can participate in a many to one and many to many, and this can participate in a many to one and many to many. It means that this book, a particular book, may be borrowed by two people and a person, and from this side it means a person can borrow more than one book. Now if we want to put in the constraint that a book can be borrowed by only one person, then we will have to ensure that this book participates in either a one-to-one or a one-to-many relationship. So we will put this. So this is different from this one without an arrow. Once the ER diagram has this arrow, it means that a user can borrow more than one book, but a book can be borrowed by only one user. If we put this arrow as well, then we define an additional constraint that a book can be borrowed by only one user and a user can borrow only one book. So we can put in a lot of additional constraints in the ER diagram, and these constraints will identify very clearly what this database is about. Let us come to another slightly trickier example. What does this mean? This means, let us forget this part. Let us forget this part. This part simply means that, okay, let us take a simpler case. Let us take only this part. What does this mean? This means that an account may be there for two customers, in the sense that two people may have an account, that is a joint account is allowed, and we may also have a person having more than one account. Both of them are allowed in this. If we want to reduce and if we want to say that a person will have no joint accounts are allowed, then what will we do? Where will we put the arrow? Will we put the arrow here or will we put the arrow here? If we put the arrow here, it will mean that the customer can participate in a one-to-one or a one-to-many relationship. So, a customer can have more than one account, but there cannot be an account which has got two customers. So, if we want to prevent joint accounts, we will put this arrow. If we want to have joint accounts and we want to prevent a person from having more than one account, we will put this arrow. But let us see this situation. What does this mean? A customer can not only have more than one account, he can have more than one account in different branches. So, now we will answer this question. What does this mean? What does this mean is the question which we will have to answer.
One person can have only one account, one branch.
Does the first statement is, does it mean that one person can have an account in only one branch? Does it mean that only one person can have an account in only one branch? No.
One branch can have only one customer.
One branch can have only one customer? No. Let us understand it very carefully. The customer in this relationship can participate in a one-to-one or a one-to-many relationship. That means you take up the relationship which is borrowed, forget this part. Take up whatever comes here and conceive of the relationship which occurs here between these two, accounts and branches, and look at it as if you are seeing it as one entity, as one relationship, one set. Then it means that this customer can participate in a one-to-many relationship with this set only. Therefore, it means this to this, an account may be there, the same account number, balance and type may be there in 5 branches, and this, since it has got no arrows here, it means that in one branch you can have 2 accounts of the same name. This is what this means if we put no arrows. So, whatever is accumulated in the relationship from these two, that set will have to this customer. So, from this customer to that set we will have either a one-to-one or a one-to-many. So, in this particular situation, a customer can have an account which has got the same name in 2 branches. It can have. A customer can have an account which has got the same name in 2 different branches. This is allowed here. Now, if we want to additionally prevent other things, then we will have to put other arrows. So, whenever there is more than one and there is one arrow here, you accumulate everything up to this point and look at the relationship from whatever is accumulated from the other entities other than this entity, and look at the mapping constraints from there. Then you will get a clear picture of what this arrow means. Let us take another example we will take the telephone example. We will take this telephone example. If I want to ensure that a staff has got only one phone, then I will put this arrow. This will ensure this is a one to many or one to one. So a staff can have many phones, but one phone cannot be shared with more than one staff member. So this is the constraint here. Whereas if I remove this and if I put, suppose this is not there, and if I put this, then it means this phone on this relationship, which is actually only this entity set, can have only one staff member, in the sense that a staff member can have one phone, but that phone may be shared. But that phone may be shared, and if I put both of them, now I have no sharing is allowed, and a person can have only one phone, but still a person may have no phones. But still a person may have no phones, and still a phone may not be allocated to a particular person. So please remember that these 1 1 many 1 1 1 does not violate or does not take into account why we set up this entity in the first place compared to this relation. That when this to this ensures that this is, every phone has got some name associated, but the mapping constraints 1 1 1 many were not induced here. The mapping constraints are induced here, and the separating out is induced here. That is, the person may have no phones, or a phone may have no persons. So these things must be understood a little clearly when you design this yard diagram, because a yard diagram really defines all the constraints very, very clearly. Next we come to, and this is true in all the other cases. When I have separated out accounts and branches, it means that an account may have no branch, or a branch may have no account. An account may not be associated with a branch, and a branch may not be associated with an account if I separate it out. But the next and more important question which comes in is, how do we put in that information? The information that in some situations some entities must be dependent on somebody else. That is the subjective information. How do I induce? For that we have what are called suppose this is my relationship between customer and account. I can now specify this I can now specify whether a customer can have more than one account. I can specify whether there will be joint accounts. A customer may have no account and an account may have no customer. This is what is the situation at the present moment. Now I want to ensure that an account must be related to some customer. Suppose I want to ensure that. This is one thing we have not been able to do till now. And suppose I want to do that. An account must be related to a customer. Then we say that this entity account is existency dependent on customer. We say that means that every element of account must have some element in customers and there must be a relationship between them. If this is existence dependent on this, then this will be called the dominant entity and this will be called the subordinate entity. And it also means that, what does it mean when you do the database? If this customer is removed, then this account is gone. This account is gone because this account has got its existence depending only on the customer. If we want to ensure that a customer must have an account, then we can do the other way around. So now we can put in these existence dependencies in a particular format, which we shall come to a little later. There are several other examples. For example, you take the airline reservation system. In the airline reservation system, a ticket is always related to a flight. If you want to say that I have purchased a ticket without a flight, I will book my flight later on, all this is allowed, then it's fine. If you want to, in the railway reservation system, if you want your ticket, a reservation ticket will always be associated with a train. So that data will be existence dependent. If you want to book a ticket, whereas the unreserved ticket will be not related to any train, that data is different. That data is not existence dependent on that train. You book an unreserved ticket from Kharagpur to Calcutta, that is different from booking a reserved ticket from Kharagpur to Calcutta by Steel Express, coach number C2, this, that. So you can express these two differently. One will be existence dependent, one will not. If this train does not exist, you cannot book a ticket on a train which does not exist. You cannot have mark sheet from a university which does not exist. There are people who have mark sheets from universities which do not exist. In order to highlight these existence dependencies and how they are related, we have to understand another notion, that is the notion of a key. We go back to one of our favorite examples. Now coming to this example, we see that by definition all the attributes are required to define a particular user, but the situation may be such that a user may be identified by a subset of these attributes. For example, a, no two users may have the same card number. If we want that no two users have the same card number, then this card in this entity set, you will never have two elements with the same card number and the other attributes different. You will always have, if the two card numbers are same, the other attributes must be different, must be same, sorry. Name, address, status and code may itself be unique. Two people with the same name, same address, same status and same employee code cannot have different card numbers. So all the attributes may not be necessary to uniquely identify an entity set. A subset of these attributes may be sufficient. Accession number may be sufficient for a book. On the other hand, title, call number, year of publication and publisher may, all of these taken other than accession number may not be sufficient to identify this book uniquely, because two copies of the same book bought in the same year in the library will have the same title, same author, same year of publication, same publisher, but there will be two different distinct books in the library and will have different accession numbers. Therefore, these four attributes may not be able to uniquely identify. This one attribute will be able to identify. If this one attribute identifies, these two together will also be able to identify. That is quite obvious. So based on this notion, we have developed the notion of a key. A super key is a set of one or more attributes which taken collectively allows us to uniquely identify an entity in an entity set. That is what we were understanding. In this example, card number is a super key, name, address, status, code is a super key according to our understanding. The whole thing taken together is also obviously a super key. Card number and name is also a super key. Card number, name and address is also a super key. Accession number is a super key. The other four taken together are does not form a super key, but accession number and author forms a super key. So we need a super key may contain extraneous and unnecessary elements, which if removed, it will still remain, that set of attributes will still remain a super key. A super key may contain, for example, accession number, author and year of publication. If you remove year of publication, these two attributes still remain a super key. If you remove this, accession number still remains a super key. Name, address, status and code. If you remove code, this may not remain a super key. You may have two people in the same mess, somehow having the same name and having the same status. You may. If you do not, then this does form a super key. But if you may have, for example, you remove code and address, name and status may not form a super key. So now we define the concept of a minimal subset of a super key, and we call it a candidate key. A candidate key is a super key for which no proper subset is also a super key. Name, address, status, code is a super key. Now suppose if I remove name, then address, status and code, suppose if it is not going to uniquely identify this, then this is not a super key. So a super key, if you remove one of, you start removing one by one. If it still remains a super key, then it's not a candidate key. A candidate key is a minimal set of attributes such that you cannot remove any attribute without failing to lose the property of a super key. So here you may have this as a super key, you may have this as a super key, you may have these four together as a super key. Now the database designer will use for every entity one of these candidate keys, because this is now you need not specify all of the, you need not use all of them, you know if I use this, these are automatic. So a database designer will choose one candidate key out of every entity and call it the primary key of that entity. A primary key is a candidate key chosen by the conceptual designer or the database designer as the chief attribute set by which an entity is identified in an entity set. So among all the candidate keys possible, the database designer will choose that this is my method of identifying the key. With these ideas, we come back to the concept of existence dependencies. Suppose we have defined this account as existence dependent on customer, in the sense that this account must have some customer. Every account must have some customer. In that case, this account is called a weak entity. because every account must have a customer, and this account is directly related to the customer, we could have put these for every account. You just give the customer primary key, you will identify the account. In a sense that each entity in this entity set does not have a primary key. You can identify the core of this fellow from the strong entity. This is called the strong entity, this is called the weak entity. A weak entity is an entity which is existence dependent, it has got no primary keys, and it is dependent on another strong entity for its identification. Every account must have some customer. That is what is meant by this definition. Now there are many things which we have gathered from here. A customer may not have any account. Every account must have some customer. If these two directions are not there, then a customer may have more than one account, and an account may be shared by more than one customer. That is a different concept from this concept. This is still allowed if we do not put these arrows. Now if we want, if we put these arrows identify the mapping constraints, one to one, one to many, many to one. Weak and strong entities identify the subjective constraints. Everyone must be mapped here, but still we cannot replace this by one entity with all the attributes of this, and the attributes of this. Why? Because a customer may not have an account. This says a customer still may not have an account. If a customer also must have an account, and an account must be related to one customer, then we can club all of them and make it into one entity. I think this should be understood very clearly. If the subjective constraints are there on both sides, then there is no need to have these two entities and this relationship. If there is only one side there is a subjective constraint and one side there is not, then one will be weak dependent on the other. If no side there is subjective constraint, then both will be strong entities. And the mapping constraints, whether it will be 1 1, 1 many, many 1, 1 many many, will be defined by these arrows. So all these are individual different concepts, and each of them makes the problem different, makes the definition different. If I do not have this, I have something else. If I have a few more arrows, I have something else. But it would be foolish to have only one with two weak entities and one relationship. It doesn't make sense. Then you can club them together and have only one entity set. Now how do we identify? For an entity set which is a strong entity set, it is defined by its set of attributes. How is a weak entity set defined? It is defined by its set of attributes and the primary key of the strong. It is defined by its set of attributes and the primary key of the strong.